Welcome to Skilled MBA Zero Friction Lecture Recording aims to seamlessly integrate technology into teaching, minimizing technical barriers.
This approach enhances educators' focus on pedagogy by simplifying the recording process, allowing for effortless content capture. By reducing complexity, educators can concentrate on delivering engaging lectures without the distraction of technical challenges.
Traditional lecture capture systems often hinder educators by requiring technical skills that detract from teaching. These systems create obstacles, diverting attention from educational objectives and complicating the teaching process. Addressing these challenges is crucial for enhancing the educational experience and ensuring that technology supports rather than impedes pedagogical goals. Current systems present friction points. Complex setups demand technical skills, consuming class time. Post-production is a bottleneck, with hours spent on manual editing and content organization. Integration challenges arise from disconnected workflows between recording systems and learning management platforms, hindering seamless educational experiences. A recent faculty survey reveals that 87% of educators face technical barriers disrupting teaching flow. Additionally, 73% spend over 45 minutes per session on post-production tasks. An overwhelming 92% express a need for seamless integration with learning management systems, highlighting the demand for a more efficient, user-friendly lecture capture solution. The zero-friction vision aims to revolutionize lecture capture by operating seamlessly in the background. It minimizes educator intervention, ensuring professional quality recordings. Automated post-processing enhances efficiency, addressing technical barriers and reducing time spent on post-production. This system promises to streamline educational delivery, aligning with the faculty's desire for seamless learning management system integration. The three-step pipeline architecture enhances lecture capture efficiency. Auto-initiation uses smart sensors to start recording as instructors arrive. Intelligent capture employs AI to detect key moments and transitions, ensuring optimal camera angles. Seamless delivery automates processing, synchronizes with learning management system, and tags metadata for searchable content, streamlining the educational experience. Auto-scene detection technology enhances recording by using visual cues to detect slide changes, board writing, and presenter movements. Audio analysis identifies topic transitions through speech patterns, while contextual markers create logical chapter breaks based on content structure. This ensures a seamless and organized presentation experience. The Learning Management System Integration Framework streamlines educational processes through automated workflows. It enables direct uploads to course modules, extracts and tags metadata, and notifies students efficiently. Additionally, it integrates with analytics dashboards, providing educators with valuable insights into student engagement and course effectiveness. Implementation results show a 62% reduction in post-production time, cutting average processing from 45 to 17 minutes per lecture. Faculty satisfaction has soared to 94%, with educators noting enhanced workflow efficiency. Additionally, content utilization has increased by 3.2 times as students access recorded materials more frequently due to better organization. The sensor layer employs motion detection, audio monitoring, and presence identification to gather data. The processing engine uses real-time AI for scene detection and content categorization. Finally, the Integration Hub connects seamlessly with institutional learning management systems and storage systems via application programming interfaces, ensuring efficient data flow and accessibility. The pilot program outcomes reveal substantial efficiency improvements. Before implementation, lecture sessions required extensive manual setup, averaging significant time per session. Post-implementation, automated processes reduce this time dramatically, streamlining workflow stages and enhancing overall productivity. This efficiency allows educators to focus more on teaching quality and student engagement. Faculty feedback underscores the system's impact. Professor Rajesh Kumar notes a shift in focus from logistics to student engagement. Dr. Meera Patel highlights the automated scene detection's role in producing professional content that captivates students. These insights reflect the system's effectiveness in enhancing educational delivery. Scalability begins with Phase 1, implementing auto capture and learning management system integration in 15 classrooms. Phase 2 introduces enhanced analytics, focusing on student engagement metrics and content optimization. Phase 3 advances to artificial intelligence tutoring, offering automated content summaries and interactive learning modules, paving the way for a more personalized educational experience. Evaluate current classroom technology and network capabilities to ensure seamless integration. Deploy systems by installing sensors, configuring artificial intelligence processing engines, and establishing learning management system connections. Conduct minimal training sessions for faculty on system monitoring and troubleshooting. Continuously optimize by monitoring performance metrics and refining artificial intelligence algorithms based on usage patterns. Transforming educational technology has led to a 62% reduction in post-production time, maintaining professional content quality. This strategic impact allows educators to concentrate on pedagogy over technical logistics. The future vision includes scalable, intelligent capture systems that adapt to institutional needs, enhancing educational delivery and efficiency. Thank you.